Okay, today we're talking about angle pair relationships. There are a few, and they're a good way to demonstrate your knowledge of proofs, which you now have. If you're wondering about all this, all of this second chapter on proofs and logic, symbolic logic, hypothesis, conclusion, all this stuff, you may get the impression that this was just invented to torture high school students. Well, you're very perceptive. That's exactly why it's there. But there are other reasons for it too. Logic has its uses. There are generally, in mathematics, there's only one kind of argument, logical, and that's it. That's pretty much true for engineering and science also. If it wasn't true, bridges would fall down, buildings wouldn't stand up. An emotional argument that 5 equals 4 might sound good, but if you base your equations on that result, nothing you construct will stand up. Emotional arguments are used a lot socially and politically. It's worth your time to learn logic. Sure, you can use emotional arguments all day if you want. It's a free country, and you'll convince a lot of people that you're right using emotional arguments. But generally speaking, logical arguments lead to violent conclusions much less often than emotional arguments. If you need one reason to at least consider being logical, you might start with that one. So let's get to some math. What about right angles? Well, I started out talking about angle pair relationships, and the first thing I talked about is a right angle, which is not a pair of anything, is it? Remember, it's that. And then we draw that little thing there to indicate that it's a right angle. And one of our theorems is that all right angles are congruent. Well, what's the definition of congruence? The angles have the same measure. What's a right angle? An angle that is 90 degrees. All right angles are 90 degrees. All right angles have the same measure, so all right angles are congruent. We're done. It's pretty easy. What's next? How about congruent supplements? Well, this is an awful lot like the transitive situation. If angle 1 and angle 2 are supplementary, what does that mean? That just means that angle 1 plus angle 2 equals 180 degrees. If angle 3 and angle 2 are supplementary, pretty much means the same thing. Now, we can either use transitivity and say that L1 plus L2 equals, angle 1 plus angle 2. Sorry, it's kind of early for me. Angle 1 plus angle 2 is equal to angle 3 plus angle 2. In fact, let's do that right here. Since they're both equal to 180, we can write it this way. Now we can use a little algebra. And I should have written the measure here. That's what that really means. Measure of angle 1, measure of angle 2 equals 180, and on and on. And we end up with we just get, boom, measure of angle 1 equals the measure of angle 3, or sticking with angle notation, angle 1 is congruent to measures are equal, the angles themselves are congruent. And here's another one that you can prove very easily, just like the previous theorem. That one involved two supplementary angles. Now, if two angles are complementary to the same angle, then they are congruent. 4 and 5 are complementary, and 6 and 5 are complementary, then 4 is congruent to 6. Makes perfect sense. Just do what we did last time, except that you put measure of angle 4 plus the measure of angle 5 equals 90 degrees, measure of angle 6 plus the measure of angle 5 equals 90 degrees, set these two equal, block out the 5s, and boom, you get the measure of angle 4 equals the measure of angle 6, and from the definition of congruence, angle 4 is congruent to angle 6. See how easy that was? Here's a couple more facts we're going to have to use. The linear pair postulate, which I think you could actually prove. This could be a theorem. But right now we might not have all the things we need to prove this. So we're treating it as a postulate. Later on you may learn about something if you take a philosophy class or in some math classes. I think it's pronounced Hakim's razor. And I've seen it spelled all kinds of different ways. I've actually heard it pronounced different ways too. I'm just sticking with Hakim's razor. Sometimes it's Hawkins razor. It's a principle of parsimony. Don't you love it when somebody defines a word with another word that you never heard of? Parsimony just means economy. It kind of means cheap. It means use as little as possible. For instance, in the middle of proving that two angles which are supplementary, both supplementary to a third angle, must then be congruent to each other. Well, I could have parenthetically included in that proof, I have a cat named Fluffy. That wouldn't contradict anything. And as long as I put it in parentheses and don't mean to imply that that is part of the argument, I could do that. It wouldn't really make it an illegal proof. It wouldn't make the proof invalid. But it would look kind of dumb. Why would it look dumb? Because you threw something in there that had nothing to do with anything. That is a violation of parsimony. That violates Hakim's razor. Also, throwing postulates and axioms around when they could be theorems, that violates Hakim's razor. You should have as few axioms as possible. In other words, in logic and mathematics, you take as few things on faith as possible. You don't accept things, you prove them. Some things have to be accepted. Remember, early on I talked about something called infinite regress, and at some point you do have to agree on a few things. But old Hakim says you need to minimize those things. So whenever I see a postulate that I think could be a theorem, it kind of bothers me, but it's not that important. In fact, as a student, what you really need to remember is the result. On a standardized test, they're very unlikely to ask you if a particular result was an axiom or a theorem. And there's a good reason for that. Some authors might include this as a theorem in their book. These authors listed it as a postulate. Since different books may do it differently, it wouldn't really be fair to hold you responsible for 15 different books. So they don't usually ask questions on that, and that's good. What you need to remember is the result. Remember those two-column proofs. If we wrote, say, addition property of equality, we didn't write parenthetically axiom. Addition property of equality, or theorem. Vertical angles congruence. No. When we use, for instance, this result in a proof, we will just say vertical angles are congruent. that will be our justification. We don't even have to write whether it's a theorem or a postulate. So don't lay awake nights worrying about whether you have to remember whether something is a theorem or a postulate. At this level, the result is the thing that you really need to remember. Vertical angles are congruent. All that means is that these two angles here, 1 and 3, are equal, and 2 and 4, congruent. Their measures are equal. The angles themselves are congruent. And angle 2 is congruent to angle 4. We'll be using these results to work out some problems also. Now let's start with a simple one here. The idea is to identify the pairs of congruent angles. Well, they listed that this is 50 degrees, and this is 50 degrees. So right off the bat, we've got MSN is congruent to PSQ. By the way, when I learned congruence, we wrote it this way. We didn't write equals with the squiggle over it. We just wrote half of the equal sign with the squiggle over it. So it was sort of half an equals and half a squiggle. So sometimes I do that. That means congruence also. And I think you'll see this in some other books, especially if you're an historian and like to look at really old books. You'll probably see this a lot. These two are congruent. Well, this is 90 degrees here, right? So these two must be complements. Remember, our angle addition postulate, these parts add up to the whole. 50 plus 40 is 90, so this one must be 40. On the other hand, this is a 90 degree angle here. So this one must also be 40 degrees by the same reasoning. So, what do we have? NSP is congruent to QSR. That's two more pairs. Now what about the right angles here? Remember I mentioned this is the right angle. Well, this is the right angle here also. So, MSP, that's a right angle. And right at the beginning, we pointed out that all right angles are congruent. And PSR. And that all right angles are congruent. Just always seems kind of redundant to me. It's like saying all 10 degree angles are congruent. Well, of course they are. If they're 10 degree angles, they have the same measure, and by definition, they're congruent. Well, that's all the congruent pairs I see. Hope I didn't miss any. Here's one that at first looks like it's right. Like, what's wrong? The line here and the line here. Oh, that's what's wrong. What we have here is a line segment, and then we got another line segment. If they had drawn this with the arrow here and then an arrow out here to indicate that this was all one straight line, then these relationships would hold. But this isn't all one straight line. This is a segment, and this segment's at a slightly different angle. And we can't just say anytime we got a group of angles laid out like this that these two are equal and these two are equal. These aren't vertical angles because this isn't all one line. This is a segment here, and this is another segment. Their slopes are slightly different. And that's the only thing wrong with this. So whoever did this, they had the right idea. They just didn't spot that this isn't all one line. This is two separate lines, and this is two separate lines So what we really have here, segments actually, is like 4 segments coming together, not 2 lines. And that's why it's no good. Pretty easy. Now here's one that combines algebra with the things you know from geometry. Now in this case we do have 2 straight lines intersecting. So we have 2 pairs of vertical angles which are equal. And our job, should we choose to accept, is to find x and y. And in this case they kind of made it easy on us. If they had thrown x and y's in all of these, we'd have 2 equations with 2 unknowns, and we'd have to do a lot more manipulating. But here we're going to have 1 equation with 1 unknown, which will be 5y equals 7y minus 34. And I would get that we subtract 5y from each side and add 34 to each side. Or y equals 17. What about this? Exactly the same way. We just write 8x plus 7, because these 2 are equal. We know that because they're vertical angles, equals 9x minus 4. Well, that's not anything like an x, is it? Let's try this one. There we go. Minus 4. So subtract 7 from each side and get minus 11 over here. Subtract 9 from each side and get minus x over here. Whoa. We're almost done. Multiply through by minus 1 and we get x equals 11. Now, what we could do to make sure we're right is check these. If y equals 17, this and this should turn out to be the same thing. Let's see here. If y was 17 times 5 would be 50, and 35 is 85. So we get 85 over here. What would it be here? Well, see, 10 times 7. That's 70 plus 49. $119 minus 34. Oh, we get 85 over here also. And this one, 88 plus 7. Is that like 95? 99 minus 4. Well, that's 95 also. Okay, we did it. Y is 17. X is 11. And all you had to do to work this equation was a little bit of simple algebra and recognize that these are vertical angles and these are vertical angles, and vertical angles are congruent. Once again, we're going to use geometry to set up an algebraic equation. A and D are complementary. So what does that mean? Let's just write down what that really means right off the bat. The measure of angle A plus the measure of angle D equals 90 degrees. The measure of angle A is 4x. Which expression can be used to find the measure of angle D? Well, if we substitute 4x in here plus measure of angle D equals 90 degrees, I would say the expression to find the measure of angle D would turn out to be 90 minus 4x. And that looks pretty much like that one, doesn't it? if you went through and looked at these before you did this, just instead of doing this independently, look at this to figure out, well, you might get trapped if you have trouble remembering the difference between supplementary and complementary. But if you remember, complementary means they add up to 90 degrees. Write it down here. You can pretty much throw out these two. Where would that come from? So that leaves you with these two, and then the question is, are you going to subtract the 4x or add the 4x? That's the only difference between these two. Here's one similar to what we did a couple of problems ago when we were asked to find x and y. This is the part here you always have to pay close attention to. Are they asking you to find x and y, or are they asking you to actually find the angle? Last time they said find x and y. This time they say find the angle, which involves finding x and y and then computing the angle from that, which we actually did last time in order to check our answer, didn't we? So this problem and the one we did a couple of problems ago, where all we had to do was find x and y, are going to be virtually identical because I checked my work at the end and computed all the angles to make sure that the vertical angles actually turned out to be equal. It's important to pay attention to this part. Sometimes, like they say, in the heat of battle, you'll get real intent on working out some part of the problem and then forget that that's only a step and that you got one more step to do, which in this case will be to actually find the angles. So let's do it. We got 10y, these two vertical angles we said equals 7x plus 4. So we got a problem right off the bat. We got one equation and two variables. So we're going to have to get another equation here. Yeah. Where do we find another equation? Well, how about these two? We know these are equal. So we also have that 3y plus 11 equals 4x minus 22. Now, if we make use of the fact that vertical angles are congruent and set up the equation that way, we end up with two equations within two unknowns, which is doable, but it's messy. There's another way we could do this. Make use of the fact that linear pairs, and that's what these two are, add up to 180. If we do that, we end up with one equation and one unknown. That's this angle plus this angle equals 180. And first thing I'm going to do is just put this all together and get 11x minus 18 equals 180. X is 180 plus 18. Gotta add 18 to each side. $198, or I think that works out to 18. Is that right? No, 10 times 1. 10 times 18 is 180. Plus 18 would be 198. Yeah, that works. Well, that's part of it. What about this over here? How about same thing, 3y plus 11 plus 10y equals 180. Yeah, I should get a bad habit of just writing all over the page. This is all one set of equations for finding x. This is where we're going to find y. And that gives us the 13y. Plus 11 equals 180. Or 13y equals 180, 169. And I'm betting that's divisible by 13. Let's see here. And I think that's 13 squared, isn't it? 13 squared is 169. So y is 13. So how does that work out? Well, 10 times 13 here would give us 130 degrees. What about this one? 7 times 18 plus 4. Let's try that over here. 7 times 18 I need to go back to arithmetic school. This is actually 126 here. 7 times 8 is 56. That's 12. 126 and 4 is 130. So we're cool here. What do we get over here? Now let's see here. 4 times 18. And if we do all the arithmetic, we get 4 times 18 minus 22 is 50. I think 4 times 18 is 40 plus 32 is 72, minus 22 is 50. That works. And over here, 3 times y, that's 13, that's 39, plus 11, that's 50. So it all makes sense. We've found x and y, and used x and y to compute the value of the angles. And the values we came up with showed that these vertical pairs of angles are equal, which is a good indication that we came up with the right answers. Also, these linear pairs, they add up to 180, just like they're supposed to. Also an indication that we got the right answer. This one is almost exactly like the last one. However, it's a little bit of difference. Always set things up in such a way as to make life easy for yourself. Before, we recognized that this was a linear pair over here because the two adjacent angles were in terms of x, and these two adjacent angles were in terms of y. In order to get one equation with just one variable, we used the fact that linear pairs add up to 180. Now we have our opposite angles, our vertical angles, all contain the same variable. This pair of vertical angles is in terms of x, this pair is in terms of y. So this one we're going to set up differently. Instead of writing that 6x plus 50 plus 7y minus 9 equals 180, no, we're not going to do that this time. We're going to set this angle equal to this angle. Again, that's just so that we can get the variables of one type all in one equation. Things work out a lot easier that way. And let's just multiply this out right off the bat, because we're probably going to have to start combining terms. So let's write, that could be wrong, but what the heck. It won't kill us to do it this way. 10x minus 10 equals what? 6x plus 50. Suppose we subtract 6x from each side, and you get that 4x equals what? add 10 to each side, and we get 60, or x equals 15. Does that make sense? Well, we can put that right in here real quick. Let's see here. 6 times 15 is 60, and 30 is 90, plus 50 is 140. What do we get here? Well, 10 times 15 is 150, minus 10 is 140. So, x equal to 15 makes sense for this pair of vertical angles. Let's see what we can do with y here. We got 5y plus 5 equals 7y, minus 9. So again, subtract 5y from each side and get 2y over here. Add 9 to each side and get 14 over here. Or y equals 7. Does that work? Now let's see here. 7 times 7 is 49. Minus 9 is 40. Over here, 5 times 7 is 35. Plus 5 is 40. These two are equal, just like they should be. It also makes sense if you think in terms of linear pairs, because these two should add up to 180. As a matter of fact, if we didn't want to do this, if we wanted to assume we were right here, we could have just written that these two were 40 right off the bat. So all we had to do was recognize that this is a linear pair. If this angle was 140, this angle has to be 180 minus 140, which is 40. We didn't even have to do this. We just did because, well, more algebra means more fun, right? Let's finish up with interpreting a diagram. It's important to be able to quickly look at diagrams and interpret what's going on. So let's take a shot at it. What about angle 3 and angle 7? Well, let's see here. Angle 3 is a right angle. Angle 7 is a right angle. Well, that means they're congruent, or their measures are equal. Right angles are all equal because they're all 90 degrees. What about angle 4 and angle 6? Let's see here. Here's angle 4, and here's angle 6. Well, they look like a vertical pair to me. That's all one line, and that's all one line. These are, make a vertical pair, they're congruent, and therefore their measures are equal. What about this one? Well, measure of angle 8 plus the measure of angle 6. Well, let's take a look at this. These three angles together make up one straight angle. And remember our angle addition postulate. If the straight angle is 180, then these three must add up to 180. So we have measure of angle 8 plus, what the heck, we could write it out here. Measure of angle 8 plus, measure of angle 6 plus measure of angle 7 equals 180. But we know that angle 7 is 90 degrees. And if we make that substitution, what do we get? Subtract 90 from both sides, and we get this measure of angle 8 plus the measure of angle 6 equals 90 degrees, right? So, wow, that was awful. Yeah, forget it. Let's just boom, boom. 90 degrees. And 90 degrees is less than 150. And you probably could have spotted that without the arithmetic. After all, this is all a straight angle. That's 180. You know this is 90. Even if you don't know exactly what 180 minus 90 is, you probably got a pretty good guess that it's less than 150. And what about this one? The measure of angle 4 is 30 degrees. That's this one here. Then what does that say about the measure of angle 4 with respect to angle 5? Well, again, they form a linear pair. They add up to 180. Which means, seems kind of obvious, that if they were both equal, then this would be a straight up 90 degree angle. If one is less than 90 degrees, the other one must be greater than 90 degrees. We don't even have to write out the equation to figure out that angle 5 is greater than angle 4. That's because they form a linear pair, and 4 is less than 90 degrees. So whatever this one is, it has to be greater than 90 degrees, which makes it greater than angle 4. Boom. All done. This wasn't real earth-shattering. It's just that it's important to be able to interpret what's going on when you look at a diagram here. You know, be able to quickly spot that 4 and 6 are vertical angles and therefore equal. These two are right angles and therefore equal. It's just about spotting the relationships between angle pairs, just like it says right here. Boom. Funny how that worked out, isn't it? Well, that's it for now. The next one will be real long. We'll be doing sample problems, which are designed to mimic the standardized test that you'll be taking later in the year. Actually, you take them periodically, don't you? You take them 2 or 3 times, but the big one, the final one that really counts, that's the last one. That's towards the end of the year, right? And of course, you'll be totally ready by then. You'll fly through it, no problem